Hello grade 5, welcome back to our video tutorial lesson, and of course in order for you to be updated with my uploads in YouTube, just subscribe and hit also that bell button to be notified of the updates and of your lessons every week. For the week 2 of our lesson grade 5, we will be dealing with lesson 1 is the divisibility rules for 4, 8, 11, and 12. And of course, we will be using these divisibility rules in getting the common factors of the set of numbers. Alright, this time I know everybody is very excited for our lesson this week. May ara pa gani mga parents nga comment sa comment section sa akon nga YouTube nga na-challenge may gano sila kag it's a way for them to check kung ang ilang brain cells are still functioning. Of course, naga-function right now. So, all you need to do is a little more try and practice para pagid ma-refresh natin ang mga nabag-an natin sa nagliligan. So at this very moment, before we'll proceed to the very meat of our lesson, I want you to do our first activity, which is a sort of review of what we have learned from our previous lesson. And the instruction or the direction for the first activity, let me read to you. See if the numbers in the first column are divisible by 2, 3, 5, 6, 9, or 10. Mark X on the corresponding columns or check if it is divisible. X kung hindi siya divisible, check kung divisible siya. So that's the only thing that you have to do. Get your notebook, grab a pen, and answer our first activity. I'll go back to you later for the answers. Pause this video and answer your first activity. Are you now excited to know if how many points will you get from our first activity? Before I will reveal to you the answers, allow me first to give you a tips in answering problems like this in divisibility rules. If they are written in columns and in rows or in table, the best thing that you have to do is first test all the numbers here at the left. If they are divisible by 2, then by 5, which has the same rule, and by 10. Okay, so first let us try if these numbers are divisible by 2. 120 is even, divisible by 2. 125 is not even, not divisible, so X. 180 is even, so check. 124 is even, so that's divisible. 660 is even, so that is divisible. Because 2 and 5 has the same rules that we are just looking at the last digit, so it would be best to skip 3 first and answer 5. Okay, let's try if all these numbers are divisible by 5. 120 ends with 0, divisible by 5. 125 ends with 5, divisible by 5. 180 ends with 0, divisible by 5. 224 not divisible by 5. And 660, yes, that's divisible by 5. Now let's try to check by 10. Because these three rules, or these three numbers, they have the same rules that you always have to look at the last digit. So let's try it by 10 first. So yes, that ends with 0, divisible by 10, not by 10, divisible by 10, not by 10, divisible by 10. This is what I told you before, that if a number is divisible by 10, that's also divisible by 5 and by 2. But not all the numbers divisible by 5 is divisible by 10. So here, divisible by 10, so that's divisible also by 2 and by 5. Okay? So let's proceed here to 3. Of course, a number is divisible by 3 if the sum of the digits. So we need to get the sum of the digits. 2 plus 1 is 3 plus 0, so 3 divisible by 3. 5 plus 2 is 7, plus 1 is 8, not divisible by 3. This one, 8 plus 1, that's 9, divisible by 3. 4 plus 2, 6 plus 3, that's 9, divisible by 3. 6 plus 6, that's 12, so divisible by 3. Of course, I will skip 9 first, even though they have the same rules, because it would be easier for me to know now if a number is divisible by 6. I will just look at the number here. If divisible by 2 and 3, automatically that's divisible by 6. Here, that's not divisible by 6. Divisible by 6, yes, of course, because that's divisible by both 2 and 3. Here, that's divisible by 6, and here, that's divisible also by 6. Now, let's try 9. So, the sum of the digits should be a multiple of 9. However, 3 plus 1, 2 plus 1 is 3 only, so not divisible by 9. This time, 5 plus 2, that's 8, that's not divisible by 9. 8 plus 1, that's 9, divisible by 9. This one is 4 plus 2 is 6, that's divisible by 9. And this one, 6 plus 6, that's 12, not divisible by 9. This is what I'm telling you also before, that if a number is divisible by 9, automatically that's divisible by 3. So all the numbers divisible by 9 are also divisible by 3. But not all the numbers divisible by 3 are divisible by 9. Good job for our first activity, and now this time, to check if how ready you are for our next lesson, let us answer the activity posted here in my mahiwagang whiteboard. Of course, I want you to get your notebook and answer this activity, but before that, allow me to read to you first the direction. The direction here says that put a check mark in the corresponding column to identify whether the numbers here in the first column is divisible by 4, 8, 12, or 11. So it suggests also that you have to write this in your math notebook, so copy and answer. I'll go back to you later for the answers of this activity after our discussion. For you to learn more about divisibility rules to complete the rules for 2 to 12, now let us reveal the answers for our second activity. Of course, our second activity will be our springboard for us to know if what's the rule that applies for 4, 8, 12, and 11. So now let's answer the column for number 4 for us to know if the following numbers here are divisible by 4. Once again, I would like to repeat the meaning of divisible. A number is divisible if it will give you a remainder of 0 if you will divide it by 4. That's the divisibility rules for 4. So, diin sa mga numbers nga ini, ang may remainder nga 0 or wala gid sang remainder kung i-divide mo sa by 4. Of course, a number is divisible by 4 if the last two digits formed is a multiple of 4 or divisible by 4. Or if the last two digits of the number are both zeros. So this time, this would not be hard for us to answer 88 because it's just only a two-digit number. And it's just easy to know if a number is divisible by 4. 8 is divisible by 4 and another 8 is also divisible by 4. 88 is divisible by 4. So the answer is check. So 48, is that divisible by 4? You could just do it mentally. 4 divided by 4, no remainder. 8 divided by 4, that's no remainder. 48 is divisible by 4. 22 this time. Of course, 22 is not a multiple of 4 because 2 here, which is 20, is divisible by 4. However, the remaining 2 here is not divisible by 4. So if you skip count by 4, it will leave you a remainder of 2 because 4, 8, 12, 16, 20, that's 5, remainder 2. So that's not divisible by 4. This one, 132, I believe that's divisible by 4 because 100 is divisible by 4, which will give you 25, and 32 is also divisible by 4, which will give you 8. So 132 is equal to 33, so that's divisible by 4. And now, 264, so 200 is divisible by 4, which is equal to 50. And of course, 60 divided by 4, that is equal to 15. And 4 divided by 4, that is equal to 1. So 264 is divisible by 4. So that's check. So that's the only thing that you have to do. So you just try to look at the last two digits here. If the number is really that big, so all you have to do is look at the last two digits. So for example, if you have 5,628,721, so you need not to divide all this number by 4. All you have to do is just try to look at the last two digits. The last two digits, is that a multiple of 4? No, it's not. So this is not divisible by 4. Now, in some cases, if you have numbers such 62,500, if the last two digits or the last two digits here are both 0, so that is divisible by 4. Another one, if we have 66,924, look at the last two digits. You need not to divide the whole number. Last two digits, so 24, that is divisible by 4. Therefore, the whole number, 66,924, is divisible by 4. That's how easy. If 4, you are just looking at the last two digits. For 8, if the last three digits form is a multiple of 8 or divisible by 8, then the entire number is also divisible by 8. This one, that's just easy, divisible by 8, because 8 and 8 are divisible by 8. If you skip count by 8, you will also reach 48. That is 8 times 6, 48. So divisible by 8. This one is not divisible by 8. This one, last three digits. So I think that would be easier if you have 132 is equal to 80, which is divisible by 8, and that is equal to 10. And of course, what is the remainder here is 52. Now, 52 is not divisible by 8, so the entire number is not divisible by 8. So, let's try this one. 264. 264. Okay, you might be wondering why I am not using the rules for 8, which is try to look at the last three digits. This is only applicable if the number is really, really that big. However, if it's not that big, you could just simply try it by dividing it by 8. So, that is equal to 3, that's equal to 24, that's another 24. So that's 3, that is equal to 24, so that is 0. So divisible by 8. Okay, allow me to give to you another example or bigger numbers to check if the number is divisible by 8 or not. Let's try 53,840. Is that divisible by 8? So you need not to divide the entire number 53,840 by 8. Try to look at the last three digits. Is this divisible by 8? Of course, because 800 is divisible by 8 and 40 is divisible by 8. So that's divisible by 8. So, also, if the last three digits, for example, 1,265,000, is that divisible by 8? If the last three digits are all zeros, then that is also divisible by 8. And how about the divisibility rules for 12? Of course, a number is divisible by 12 if a number is divisible by both 3 and 4. We all know that 3 and 4 are both factors of 12. And these two factors of 12 are relatively prime, or their greatest common factor is 1. Therefore, a number is divisible by 12 if it is divisible by both 3 and 4. That would be easier for us now to answer this column because we already have here the test for 4. So, let's just try to check. Automatically, number 3 is not divisible by 12 because it should be both 3 and 4. This number 22 is not divisible by 4, so automatically that's not divisible by 12. So let's try 88. If the sum of this is divisible by 3, the fact that that is already divisible by 4, so automatically that would be divisible by 12. So 8 plus 8, that's 16. That's not divisible by 3, but that's divisible by 4. Therefore, because it's not divisible by both, so that's not divisible by 12 likewise. Here, 48, that's divisible by 3 because 4 plus 8 is 12. So that's divisible by 3, and at the same time, that's divisible by 4. So automatically, that's divisible by 12. Now, let's try this one. 3 plus 1 plus 2, that's 6. So that is divisible by 3. And at the same time, that's divisible by 4. So that's also divisible by 12. And finally, 6 plus 4, that's 10, plus 2, that's 12. So divisible by 3. So that's also divisible by 4. So divisible by 12. Again, I would like to repeat, a number is divisible by 12 if it is divisible by both 3 and 4. And finally, how will we able to complete the table? What's the answer for the last column? What's the rule for 11? The divisibility rule for 11 says that if the difference of the sum of the alternating digits is a multiple of 11, then that is divisible by 11. Again, kung ang answer ko no sa pag-subtract nimo sang sum sang alternating, magsin kita alternating balot-balot nga mga digits is a multiple of 11, then that is divisible by 11. What do you mean by that? So the best thing that you have to do is grupuhon. You have to group the numbers or the digits of the number into groups. 5,323 as our example for divisibility rules of 11. I label the first digit here as first, second, third, and fourth. The digits are placed in odd places and even places. All odd places such as first and third places, second and fourth places for even places, they are grouped together. So all you have to do is to get the sum of the odd places. So 5 and 2. So 5 plus 2 is equal to 7. And of course, you will also have to get the sum of the digits in the even places, second and fourth. So that is 3 plus 3. Liwaton nakon, ang tanan nga digit nga ara sa may odd places, such as first and the third places, add ang first or 1 and third nga 3, i-add nimo sa, i-plus nimo sa. Ang even places such as second and fourth, i-plus man nimo siya. After that one, that you already have their sum, then you get their difference. The sum is 7, the sum is 6. So, all you have to do is to get the difference of 7 minus 6, which is equal to 1. If the answer or the difference is a multiple of 11, such as 11, 22, 33, 44, 55, so on and so forth, then that is divisible by 11. Okay? So, if the difference is 0, likewise, that is divisible by 11. Example, if we have here 88, so this is the first digit, this is the second digit. You need not to add because they only have single digits because the number is very small. It is, you will appreciate more the rules for 11 or the divisibility rules if the number is really that big that you are challenged to give the answer automatically. So in this case, first is 8, second is 8. So the total of odd is 8 odd places. The total of even places is also 8. So their difference is 8 minus 8. That's 0. So that's divisible by 11. Let's try for 48. Of course, you could just simply skip count by 11. So 11, 22, 33, 44, it will not reach 48. So that's not divisible by 11. Let's try 22. Okay, that's divisible by 11. That's just easy. 132. So this is odd places, first and third. So 1 plus 2 is equal to 3. The even places, that's only 3. So 3 minus 3, the answer is 0. So that's divisible by 11. And finally, this is odd places, the first and the third. So 2 plus 4 is equal to 6. The even place, there's only one digit at 6. So 6 minus 6 is 0. So that's also divisible by 11. Good job, grade 5 pupils. After we already learned the divisibility rules for 4, 8, 11, and 12, we do have here another challenge that needs our skills in divisibility rules in order for us to answer what is written in the mahiwagang whiteboard. And the question here is, find the common factors of 264 and 176 using divisibility rules. Okay, so this time, we have to look for the factors of 264 and 176 using the divisibility rules. Are you ready? Now, What are the factors of 264? Of course, because we already learned before that any number has always a factor of 1, and we have to look for a pair of factors of 264. So the first one would be 1 times 264. Because we already learned all the divisibility rules from 2 to 12, it would be easier for us to look for other factors of 264. Obviously, 264 is an even number, so we also have a factor of 2, and that is 2 times 132. The next thing that we have to consider is that 264, if you will add 4 plus 6 plus 2, that is equal to 12. So obviously, that is divisible by 3. So that is 3 times 88. The next thing that we have to do is to check if this number is divisible by 4. So 64, the last 2 digit, that is divisible by 4 because that is equal to 16 times 4. So therefore, the whole number 264 is also divisible by 4. And what is to be paired with 264, or what is to be paired with 4 to get the product of 264? That is 66. The next thing that we have to do is to check if this number is also divisible by 6. Because the number 264 is divisible by 2 and at the same time by 3, so therefore that is also divisible by 6. Oh, by the way, I skipped 5 because I know that this number is not divisible by 5, the fact that the last digit is 4. So I just skipped 5. This time, I believe that this number is divisible by 6, the fact that 2 times 3 is equal to 6. So it's divisible by 2, divisible by 3, so therefore that's also divisible by 6. And what's to be paired with 6? That's 44. So 6 times 44 is also equal to 264. You try also to divide this by 7, but that's not divisible by 7. By 8, obviously, because it's divisible by both 4 and 2. Therefore, that is also divisible by 8. That is equal to 8 times 33. You might be wondering, how did I get 33? So all you have to do is divide 264 by 8, and the answer is 33. This number is not divisible by 9. The fact that 4 plus 6 plus 2 is only 12. That's not a multiple of 9. Therefore, we skip 9. We also skip 10 because it does not end with 0. How about 11? I think that's divisible by 11 because 2 plus 4 is 6 minus 6, that is 0. So that is equal to 11 times 24. After 11 by 12. Obviously, because this number is divisible by 3 and by 4, so that is also divisible by 12. So that is equal to 12 times 22. You could continue that to 13, but it's not divisible by 13, by 14, 15, 16, 17, 18, 19, 20, 21, 22. Yes, that is divisible by 22. 22 actually is here. It appeared here. So that is divisible by 22. Because you already have 22 here, that simply means that you already completed all the factors of 264. So the next thing that you have to do is to write the factors, all the factors of 264 here. We already have here the complete factors of 264. And now, let's try to check what are the factors of 176. So, what are the factors of 176? We will do the same. So we will have to look for a pair of factors that will give us a product of 176. Starting with, again, with 1 and 176. The next pair is, that's an even number, so that is 2 times 88. Of course, that number is not divisible by 3 because 6 plus 7, that is 13 plus 1, 14, not divisible by 3. By 4, yes, that is divisible by 4 because the last 2 digit is 76, and that is equal to 4 times 44. By 5, obviously it's not divisible by 5 because it does not end with 5. By 6, obviously not by 6 because that's only divisible by 2 but not both to 2 by 2 and by 3. Not by 6, not by 7. Let's try by 8. Yes, that is divisible by 8 because 2 times 4 is equal to 8. So that is equal to 8 times 22. By 9, obviously it's not divisible by 9. By 10, not divisible by 10. By 11, I think that's divisible by 11 because 6 plus 1, that is equal to 7. And minus 7, so that is equal to 11 times 16. Okay, by 12, I think it's not divisible by 12 because there is no 3 as another factor here. It's supposed to be divisible by both 3 and 4. Okay, so you continue by 13, by 14, by 15, not. By 16, 16 is already there. So that simply means that our factor is already complete. Now, the next thing that we have to do is to list down also the factors of 176 and later compare it to the factors of 264 to get their common factors. So there you have it, the factors of 264 and 176. After you already have the factors of these two numbers, the next thing that you have to do is to look for their common factors. So encircle their common factors such as 1, then there's 2, there's 4, there's 22. Help me to do this one. Are there some more? Yes, there's 44. There's another one, 88. Did I miss something? Or did I miss a number? No more? This time, list down the common factors. 1, 2, 4, 22, 44, and 88. This is what we call common factors. Alright, we already have the common factors of 264 and 176 using the divisibility rules. So that's our answer. And a question with that. Okay, we're already done with the divisibility rules for 4, 8, 11, and 12. And we also used all the divisibility rules in getting the common factors of 2 or more numbers. At this time, you will be answering the independent activity 1, and I will be showing you your next activity. Here it is. For your independent activity 1, the instruction here says that use the divisibility rules for 4, 8, 11, or 12 to list down all the factors of each pair of numbers. So we do have here 160 and 320, 132 and 264, 528 and 396, 288 and 120, 240 and 112. Then encircle their common factors. So later I will give you the answers for this activity. So this time you have to pause this video and answer. Are you done? Are you now ready to know what are the answers for our independent activity 1? I'll show you the answer right now. 1, 2, 3. So these are the answers for your activity. Okay, what is written here are the numbers. Supposedly, these are the numbers you encircled in each pair of factors. So for 160 and 320, that's 1, 2, 3, 4, 5, 10, 32, 40, 80, and 160. Please check your work. And for number 2, that's for 132 and 264, the answers are 1, 2, 3, 4, 6, 11, 12, 22, 33, 44, 66, and 132. And for 528 and 396, 1, 2, 3, 4, 6, 11, 12, and 66. And for 288 and 120, 1, 2, 3, 4, 8, and 12. And finally, for 240 and 112, 1, 2, 4, and 8. Well done, guys. At this point, we will proceed now to our independent activity 2. So what could you see here on my mahiwagang whiteboard are the things that you need to copy in your math notebook. So all you have to do is listen to the instruction. Using the divisibility rules, write down or write through on the blank if the number on the left column is a common factor to the numbers on the right column. So if not, you just write false or not. So again, try to check if this is a common factor of these two numbers. If 8 is a common factor of these two numbers, 11 for these two numbers, 12 for these two numbers, and 12 for these two numbers. You try it, pause the video, and do your independent activity 2. I'm so excited. Now let's check your activity or independent activity 2. 192 and 670. Is 4 a common factor of these two numbers? The correct answer is not. Why? It's because 92 is divisible by 4, but 70 is not divisible by 4. So obviously, 4 is not a common factor of these two numbers. For number 2, that's 432 and 864. Allow me to explain this a little more. 400, because we are looking at the last 3 digits. Unfortunately, these two numbers are both 3-digit numbers. So we really have to work out with the numbers by dividing this by 8, by dividing this by 8. However, if you know the mental division, then it would be easier for you to solve the problem. Because we all know that 400 is divisible by 8 and 32 is divisible by 8, so 8 is a factor of 432. At the same time, 800 is divisible by 8 and 64 is also divisible by 8, so 8 is also a factor of this number. So both of them, 8 is a factor. So the correct answer is yes, that's divisible. For 11, for these two numbers, 4 plus 2, that is equal to 6 minus 6, so that's divisible by 11. 3 plus 0 is equal to 3 minus 3, so that is equal to 0. Therefore, yes, both of them are divisible by 11. And now for 12, I know that 24 is divisible by 12, or 240 is also divisible by 12. But I'm not quite sure if 500 is divisible by 12. The only thing I know is 60 is divisible by 12. That is 60 times 5 is equal to, what I mean is 60 divided by 5 is equal to 12. So I think 50 or 500 is not also divisible by 12. So the answer is not divisible. Okay, and finally 480 and 960. I'm sure that this is divisible by 12 because that is 12 times 4 is equal to 48. So 480 divided by 12, that's divisible. 960, I'm sure that that is also divisible by 12. So the correct answer is yes. So how many points did you get? In your activity or independent activity 3, you will just only tell if to what number is 154 and 132 divisible. Is it divisible by, the choices are 4, 8, 11, and 12. So all you have to do is just shade if it is divisible, shade 4 if it is divisible by 4, shade 8 if it is divisible by 8, shade 11 if it is divisible by 11, and shade 12 if it is divisible by 12. So get ready, for I will now reveal the answer. However, if you are not yet done, pause this video. Time is up, and the answers are, for number 1, that's 11. For number 2, you will just shade 4, 8, and 12. For number 3, that's 12 alone. For number 4, that's 4 and 11. For number 5, that is 4 and 8. Who got a perfect score of 5? So, this time, let's wrap up what we have learned today. A number is divisible by 4 if the last two digits form a multiple of 4 or divisible by 4, or both last two digits are zeros. A number is divisible by 8 if the last three digits form is a multiple of 8 or divisible by 8, or the last three digits are all zeros. However, a number is divisible by 12 if it is divisible by both 2 and 3. It simply means that the sum of the digits should be a multiple of 3 and it should be an even number. And finally, a number is divisible by 11 if the difference of the sum of the alternating digits is 0 or a multiple of 11. So, we are done with all the activities that we need to prepare ourselves before you will take the assessment. The assessment will measure if how much have you learned for our today's lesson. And of course, this will be the last activity that we have to do. This is reflected in your What I Can Do, page 11 of your Module 3. So the question here is, how many whole numbers from 20 to 40 are divisible by 4, by 8, by 11, and by 12? Let us now answer our last activity. How many whole numbers from 20 to 40 are divisible by 4, by 8, by 11, or by 12? So let's start with 4. Remember that our answer is only from 20 to 40. So it simply means that 20 and 40 are included in our options. So 4, of course, the numbers that are divisible by 4 here are 20, 24, 28. Let me list down those. 20, 24, 28, 32, 36, and 40. So 1, 2, 3, 4, 5, 6, 6 numbers. How about by 8? So the numbers which are divisible by 8 from 20 to 40 are the following. Let's start with 24, 32, and 40. So we have 3 numbers. And how about for 11? These are 11, those are 22 and 33. So 2 numbers. And for 12, so those numbers are 24 and 36. So there are also 2 numbers. So these are the answers for our activity. Thank you so much for joining me in this Module 3 video lesson. So this time, I want you to take out your pad paper or intermediate pad and answer your assessment. Thank you so much. See you for our next video lesson.